So we're going to have a look at how do we make maths accessible to students with additional learning needs? What steps do we do to make sure students can access the maths in our lessons? So using our existing resources, are they accessible to everyone? And how do we bring students' handwritten homework from outside the classroom into us at school or college? And how do we assess that work? EquatIO allows you to make equations, formulas, and more. We're really just going to touch a little bit on EquatIO today. There's so much more that we can show you on this. Really important thing just to head off at the beginning is that it can be a computer reader for maths. So it meets JCQ regulations and that it can be used in exams. So if your exam is PDF based, like a GCSE maths exam, you can use EquatIO with your students. What does that mean for you? Well, it means that the students have a consistent reader, but also that manpower can be deployed in other areas that would have been used for reading for maths exams. But what we need to do is build student confidence with this tool, get the students familiar with this tool. Seeing it for the first time on the day of the exam isn't going to put them in the best frame to get going. So if we think about EquatIO as a whole school approach, how does everybody teach maths? How does everybody include numbers? How does everybody draw their graphs? EquatIO really does cover all that off for you. One of the things that I really use EquatIO for is giving students worked examples. We know it's one of Rosenshine's key principles, giving them that model and that worked example. And I know the Education Endowment Foundation research also says that a worked example lightens that cognitive load for students. So we're going to take a look at how we can use EquatIO in that and making it accessible with things we already have. Then if we think about the essential digital skills qualifications in colleges, entry level is to use a suitable application to enter, edit, and format information. And then level 1 is using applications to edit, format, layout information, text, tables for a range of purposes and audiences. So what we can do is we can bring that cross-curricular learning of development of digital skills into the maths lessons as well. So when the Education Endowment Foundation looked at the research for metacognition and self-regulated learning, they came up with 7 recommendations. Recommendation 2 is about explicitly teaching how to plan, monitor, and evaluate their learning. And so as we go through, you'll see how we think EquatIO really develops that skill, gives an opportunity for us to explore that skill quite a lot. So as you can see, I am in Google Chrome, and this is a PDF. One of the most exciting resources you will ever come across in your teaching. But what it is that we are trying to evidence here how we would use an existing PDF to make it accessible to the students. Students don't need any complicated knowledge, any extra skills. How are we going to take this PDF and make it accessible? So if we turn on EquatIO here, and we're going to pick up the screenshot reader. Now, this is what's called the EquatIO toolbar. There's lots of different bits and pieces in here, and we can talk through all of these. But like I said, we're going to look at some of the key features that we have today as well. So we're going to start with the screenshot reader on here, and I'm just going to pick up this first fraction here. So that's playing the maths aloud. It's making it accessible to the students. The students can read and understand that. What we've particularly found is that if a student is learning English, perhaps they know what this is in their home language, but they don't quite know what the English is. EquatIO really helps students develop that knowledge of the key terms in maths that we use in English and what they're called. Because once they've learned that that is a fraction, and that's the English term for a fraction, they can go into the equation editor. And in the equation editor, if they start to type in fraction, it'll bring up that fraction line for them. No more of that toggling between equation editor in Google Docs or Microsoft Word. And it's in student speak. So the student knows it as a fraction. They don't know it as the button that they need to click. They know it as a fraction and they can start to type and they can build their fractions. So this is called the equation editor. It's got loads of things built into it. So you can start to type in, I don't know, you might want to talk about the area of a square, a circle, a rectangle, and they're all in there already for you. You can turn these predictions off if you think they're going to be too helpful for your students. It's customizable for you. But certainly for me with my students, I think a lot of mine have English as a second, third, or fourth language. And so it's just really important that they can connect with what it is in English, what it is in their home language, and they can marry the two together. So also along the bottom in this toolbar, then we've got the LaTeX editor, and we will take a look at that today. We have a graph editor, and this runs on Desmos. So if you're familiar with Desmos, it's now in here for you as well. But also our Desmos is accessible, so you can use speech as well in there to really support all your students as well. Handwriting recognition, literally taking handwritten maths using an additional touchscreen device or a tablet and putting it on the screen. Speech input as well for those students who are unable to handwrite or actually find it easier because of their processing issues to speak aloud, they're working out, really useful for that. Mobile we will take a look at today. Also MathSpace we'll take a look at, and Screenshot Reader I've just shown you on there as well. Okay, so we're going to still use that tool, that screenshot reader that we used on that PDF, but this time we are on YouTube with my absolute favourite Corbett Math. So I'm going to pause the video, I'm going to take that screenshot reader and I'm going to drag it over that handwritten maths. So this is handwritten maths that has been videoed and is now on YouTube, and I am able to screenshot that and make that accessible for the students. And what we can do is we can then use this 3 dots bar here, and we can copy the LaTeX or we can edit with EquatIO. And what that would do is put that in the equation editor, and then we can customize it, we could solve it, all sorts of different things that we can do with it. But it's a really important feature. Also, if we go to a website, so you might have questions that your students complete. This is Maths Kitchen, Hegarty Maths, all sorts of different places where students might complete their outside the classroom work. If we take that screenshot reader again and we drag it over this question here, the whole question, and that's now being read aloud. So perhaps they're answering this question, they get it wrong and they need some help and support. What they can do is they can copy it, or they could edit with EquatIO, and then they could paste it somewhere else for you to take a look at. And it's then editable. They can start to explore what happens if I change that number. What are they called? Oh, they're parentheses or they're brackets. And it just develops that development of the language of maths and that understanding of maths that we have as well. What we're trying to show here then is that students don't need any complex knowledge. We can use existing things that we already have and we can make them accessible, but also lighten that cognitive load for students and help them to develop that love of learning maths and that language of maths as well. So we looked at a PDF, we've looked at a YouTube video, and we've looked at an online platform. I've got a Google Doc here, same principles in Microsoft Word if you are a Microsoft organisation. Just for the purposes of this demo, I'm staying in Chrome just so it's a little bit easier. Sits at the top here is this extension EquatIO. If you are a Microsoft Word user, it sits on your desktop and it opens up as well for you. So we go open up the EquatIO and we've got here some handwritten maths that we've inserted as a photograph. Perhaps we've modelled the example. We've used that teaching of Rosenshine's principles, and we've done that worked example to model how an expert, us as the teacher, would solve this problem. And we've inserted it as a photograph for the students. We can take the screenshot reader, we can drag it over that. So it's not just reading the handwritten maths, it's reading the image of the handwritten maths. And you can see it is vertically, huge thing for us as maths teachers, isn't it? That vertical math and the importance of it. It has picked up everything that we wanted to say in there as well. It's made that image accessible for those students who need it read aloud for them. But it's also now made it so that our students can explore and manipulate that as well. They can start to think about, oh, what would happen if we did this? What would happen if we did that? What would happen if we did this? So If we have a look at these questions underneath, so this typical worksheet, we've got the example at the top and we've got 10 questions underneath. You'll see here, these ones were written in Equation Editor and these ones are just written as text. If I just pick up the screenshot reader again and just read that first one, which was written in the Equation Editor, it's picked it up and it's read it aloud beautifully for me. If I do it under here with the ones written as text, say we've got the question written as text in our document, we've quickly typed it, and we want to format into our beautiful maths writing with our curved X's, our italics. We can pick it up, and we can edit in EquatIO, and you can see it's there. And if we go Insert Maths, that will then pop that question in for us in that beautifully formatted maths writing that we want our students to become familiar with. The other thing we can do, and I talked about this at the beginning, is we can model live with EquatIO as well. We've shown it using our existing resources, but we've got here what we call EquatIO Math Space. Think blank whiteboard, think note space, think however you want to think about EquatIO Math Space. For me, it is a space where I do those annotations, where I solve those problems, where I quickly scribble down ideas. But also, if we take this worksheet here, where do the students answer this? Do they answer this on a pen and paper at home? Okay, great. Then EquatIO Mobile, which we'll come to next, really useful. But what if we wanted students to be able to answer this digitally, or to explore, or to make their own handwritten notes? Where is the space to do that in here? So if we take the question, and we've got it here, we already copied it, but we'll copy it again. So we'll take the screenshot reader and we'll take question 9 this time. We'll copy it. And we're going to click copy the LaTeX. So we're going to copy the LaTeX. And what we're going to do is we're going to take that into this math space. So this is the whiteboard area. You'll see the toolbar is exactly the same. Equation editor, but we can go to LaTeX this time, paste it in. You can see it's formatted it in our beautiful math speak, but we can pop it on here. And what we can then do is we can start to answer it. We can freehand draw. So we might want to do -27 from both sides and start to work it out. We can also handwrite our maths. So if we just clear that one off, we might want to handwrite in 50. And you can see I'm going off the page, but that's okay, it's still picking it up. 51 take away 27 is 16. Well aware that that's incorrect. And we can insert that maths. And we talked about explicitly checking our work. How do we create opportunities for students to explicitly check their work? Well, they've inserted that maths. Yep, great, sorted, done. Hang on a minute, 16 plus 27, let's do the inverse. Let's reverse that calculation. No, that's not right. What we can do is we can click on it and we can edit the maths. So we can edit what we just put in. So what might that answer be? So 51 take away 27 is 24. And then we can replace that maths and you can see it's changed on there as well. But if we go back to our worksheet here, where we have the highlighted question, we're going to copy the LaTeX again. Going to come back to our blank whiteboard math space here, go to the LaTeX, we're going to paste it in, and we're going to insert the maths on here. But what we might want to do is we might want to make this question slightly different. We found a really good question in a textbook, and we want to create 5 more questions that develop the same skill with our students. So we're just going to change that number, and that's that question. And then we would go to the next page, open the LaTeX again, and this time we might change it to 17 and insert the maths like that. So we can take that existing resource, make it accessible, make it read aloud, but we can then copy and paste it into another space, giving students free space to answer it all around it and explore their understanding. But we can customize it and create additional questions just with a click of a button, just changing the figures, something that, you know, saves us loads of time. While we're in here as well, we might have handwritten notes and we can insert those handwritten notes as well as an image if we want to, or the students can as well. But we will take a look at mobile as well. But imagine if we wanted to visualize some maths or scaffold for some students, perhaps they need a little bit extra. What we can do is we've got full shapes as well. You'll notice this one didn't exist when we were in the document. It sort of ended across here. Now we're in math space, we can pop shapes in. So if I pop in fraction bar 4 segments, perhaps we're wanting to model something for our students to visualize the problem that we're solving. So it's reading aloud what the description of that fraction bar is for our students. If we wanted to take it a little bit further, we can put in smart shapes of fraction bar and we can toggle the number of segments and the number of shaded segments as well to visualize and solve those problems. Certainly with my students, sometimes a visual really does help them as well. If we go to another space here, one of the biggest things for me for teaching decimals is money. So if we pop in the coins, we can drag and drop in all the coins that we need. And what we can do is we can use what's called infinite cloner. And what this does is it means that the student has infinite access to those coins. So if we turn it into student view, and I'll just do that now, that student can use those as many times as they want to solve a problem. So I'm just going to share this space. So you can use this yourself, you can share it with your students, but you can also expect a response and grade and mark. So everything I've just shown you, you can use to grade and mark student work as well. And you can share it, it's a web link, and you can share it in Google Classroom, you can drop it in your Teams, wherever you want to paste it, whatever your learning management system is. I'm just going to open this one up here. I'm going to toggle onto my other account. So this is me as a student, logging in as a student. Opens up the math space. Everything that I've done already will be on there for me. So those examples that we copied the latex across, the beginning of the working out and that little fraction, but here are the coins. So I'm trying to work out the answer to this problem. My teacher has put this scaffold on my page for me so I can begin to solve. It's 5, 10, 15, 20, so it's 0.2, 30, 0.4. So the answer is 0.4. 0.4. And for those students who lack the confidence to pick up that pen, pick up that paper, they can start to work out how they might solve that problem using the speech tools or using manipulatives to help them. And it's not just the manipulatives that the teacher gives them, they've then got access underneath. And what they might want to start to explore is perhaps a polygon and the number of vertices changes on there. Or what's really lovely as well for those that need it is base 10 blocks. And we've got them in 3D and we've got them in 2D. And if those are infinitely cloned and then they've got the 10 rods, then they can start to build those concepts that they're trying to grasp as well. So I promised it all along, and I'm going to have a look at mobile for you now. So if we take the question that we had originally, this one, 3w plus 27 equals 51, or we could take the first one here. Now this one was written in equation editor, so we'll take this first one. 3e plus 2 equals 17. So imagine I've handwritten that answer and I'm going to send you as a student a copy of my work. So I'm going to scan that QR code. You can see it's picked up the web address and I'm going to go to the website. So you can see on my screen all the steps that I need to take. So I'm just going to sign in with Google. Pick my account. It's going to sync it all up. And it's going to have a look now for any active documents. So anywhere where I am currently active, and you can see I'm in this math space. So if I go here, it's also got copy of equation editor algebra that I've been working on, but it's this one, the most recent one that I'm working on, that I'm going to click. So I've selected that on my phone. Okay, so your maths will appear here. Press the tool to get started. So I'm going to press that camera icon there, that camera icon, and you're going to see the maths that I've got. So you can see there is my answer to that question. So I've scanned that picture and I'm just going to drag the shape to capture all the maths and hit the green button. And I can save as math or save as image. So I'm going to save as math. And it's going to insert that in there for me. Now, what's happened here is it hasn't inserted everything. So I'm going to give it another go. So you can see I've got the maths there. I'm going to hit the button. I'm going to drag the square over that maths, and then I'm going to hit save as math. You can just insert it as an image. It's also great for doing that. But I'm going to insert save as maths. And you can see that's there. And I hit that blue button to insert it into the document. And as if by magic, there it is in the document, and you can see it. Now, what I can do as a student is I can see that it's actually missed some of the bits off. This one's also missed some of the bits off when it scanned it in as well. So I'm going to get rid of that one. Thinking about explicitly teaching students how to check their work, we can edit the maths, and it was 3e plus 2 equals 17 was the question, and we can replace the maths. So we're encouraging students to give it that sense check. It's scanned it in, it's checked the maths. How has it found what we're looking for? Do we need to make any edits and adjustments? And it's promoting that self-check before that work is handed in.